A couple of days ago, an AI model spent 48 hours alone in a sandbox and came out the other side with a working computer chip. Not a sketch, not a diagram. An actual chip that was simulated, verified, and running code. And the code it was running? A tiny version of itself. That's Kimi K3, the new flagship model from the Chinese lab Moonshot AI. For the last year, everyone in Silicon Valley has been telling themselves this comfortable story that Chinese AI labs are way behind, like 8 months or more behind the US. Well, today's launch completely kills that idea. We knew Moonshot was cooking something big, but Kimi K3 is on a completely different level. It's going head-to-head, and in some areas even winning, against the most expensive private models out there. The exact ones that are so powerful they're literally the first models to be regulated by the government. So how does a model actually pull something like that off? It comes down to two major elements, sheer parameter scale and a highly efficient architecture. Let's talk about the size first. Kimi K3 is a 2.8 trillion parameter model. To put that in perspective, it is currently the largest open weight model available, making it about 75% larger than DeepSeek's biggest offering. But Moonshot didn't just brute force this by throwing more parameters at a standard transformer. Doing that would make the model too slow and expensive to run in production. Instead, they designed two key mechanisms under the hood to manage this scale, Kimi Delta Attention or KDA and Attention Residuals. You don't need a computer science degree to get why this matters. In standard transformers, as you feed the model more text and stack the layers deeper, information starts to degrade. It's similar to a game of telephone where the message gets distorted as it passes along. KDA and Attention Residuals act like a direct high-speed bypass, allowing data to flow smoothly through the network without losing accuracy, even when you're dealing with massive context. They also optimize the mixture of experts design. Out of K3's 2.8 trillion parameters and 896 specialized experts, the model only activates 16 experts at any given time. This high level of sparsity is why K3 achieves about 2.5 times the scaling efficiency of Moonshot's previous generation. It is a massive brain, but it only powers up the specific circuits it needs for the task at hand. But where this architecture is particularly practical is in coding, specifically with a capability Moonshot calls vision in the loop. Most traditional coding models are text only. You give them a prompt, they output code, and if there's a bug, you have to manually copy the terminal error and feed it back to them. K3 handles this differently. Because it has native visual understanding, it can actually observe its own output. If you ask it to build a web application, it can write the code, render the page, take a visual screenshot to inspect the layout, read the terminal logs, and automatically debug its own work in a continuous cycle. It handles the trial and error process on its own. This ability to cycle between writing code and analyzing visual results makes it highly effective for front-end engineering, game design, and CAD workflows. It isn't just predicting the next line of code, it is evaluating the actual output of its actions to determine the next step. When you pair that active reasoning with a 1 million token context window, the model can hold an entire repository in its working memory, allowing it to navigate large projects and operate autonomously for extended periods. Testing a model's actual utility requires looking at the benchmarks. Let's look at how K3 holds up when put side by side with the current closed-source flagships from OpenAI and Anthropic. First, let's look at the Artificial Analysis Intelligence Index, which acts as a blended baseline for overall model capability. Kimi K3 scored a 57, placing it third globally. The only models scoring higher are Claude Fable 5 and GPT-5.6 Sol, the highly guarded proprietary flagships. K3 managed to outscore Claude Opus 4.8 and GPT 5.5, which is a significant achievement for an open-weight model, but practical utility is where K3 is designed to focus. On the GDP-Val benchmark, which tests models on real-world tasks across 44 different occupations in finance, engineering, and other industries, K3 scored 1668, placing third and outperforming Claude Opus 4.8. On AA Briefcase, which evaluates long-horizon agentic knowledge work like deep research projects, K3 climbed to second place overall with a score of 1547, edge casing past GPT 5.6 Sol and sitting just behind Claude Fable 5. For data retrieval, K3 scored 91.2 out of 100 on BrowseComp. This test requires models to search, synthesize, and find specific, hard-to-locate information across the web. This result suggests that its 1 million token context window is highly functional, maintaining solid retrieval accuracy without relying on aggressive context compression. When we look strictly at software engineering, K3's performance is highly competitive. On Program Bench, which covers general coding tasks, K3 takes the top spot globally with a 77.8, ahead of both Fable 5 and Sol. On SWE Marathon, a benchmark testing sustained software engineering performance, K3 leads the pack with a 42.0. On Terminal Bench 2.1, which measures command line and terminal proficiency, K3 scored 88.3, narrowly beating Fable 5 and trailing Sol by a mere half point. For highly complex frontier tasks, it remains competitive but sits slightly behind, scoring 81.2 on Frontier SWE compared to Fable 5's 86.6 and taking third on Deep SWE with a 67.5, right behind the two proprietary leaders. The broad trend is clear. K3 is a highly capable coding model that trades wins with the absolute best closed-source models in the industry. This is backed up by human evaluation on Arena.ai's front-end code arena. In the blind, side-by-side comparison for front-end coding specifically, human developers voted Kimi K3 to the #1 spot, placing it above both Claude Fable 5 and GPT-5.6 Sol. When developers evaluate the actual functional layout and code quality, they are consistently choosing K3. Automated benchmarks only tell part of the story, so Moonshot tested K3's capabilities on highly complex, long-horizon tasks to observe how it behaves over extended runs. The first was the 48-hour chip design project we mentioned earlier. Moonshot placed K3 in a sandbox environment equipped with standard hardware design tools and tasked it with creating a functional microchip layout. Over a continuous 2-day run, the model read documentation, resolved routing constraints, simulated the design, and corrected errors entirely on its own. It eventually produced a tiny, verified 4 square millimeter chip design containing 1.46 million standard cells that was mathematically capable of running a miniature version of the model itself. In another test, they tasked the model with reproducing a highly complex astrophysics calculation regarding neutron stars, a project that typically takes a senior researcher up to 2 weeks. K3 completed the process in roughly 2 hours. It navigated over 20 research papers, wrote several thousand lines of code, cross-referenced its calculations against established data, and generated an interactive interface to display its findings. They also tested its vision-in-the-loop architecture by asking it to build a 3D open-world game inside a web browser. K3 wrote the generation logic for terrain, foliage, and lighting. It actively ran the game engine, analyzed visual screenshots to check for clipping or lighting rendering errors, and rewrote the source code to resolve the bugs it saw. Finally, they had the model construct a software compiler from scratch. K3 successfully built its own Triton-style compiler that, in certain performance runs, executed code faster than standard human-engineered tools. These test cases show that K3 is capable of executing structured, multi-step projects independently for hours at a time. But none of that matters if the pricing is out of reach. But it's not. The Kimi K3 API is priced at $3 per million input tokens and $15 per million output tokens. To put those numbers in perspective, that is the exact same price as Claude Sonnet 5. But when you compare it to the absolute heaviest hitters in the industry, the gap is massive. For example, Claude Opus 4.8 costs $5 input and $25 output. OpenAI's flagship GPT-5.6 Sol costs $5 input and $30 output. And the top tier Claude Fable 5 sits at an expensive $10 input and $50 output. Essentially, Kimi K3 gives you near Fable level performance at about a third of the cost. Importantly, it uses automatic prompt caching. If you are sending repeated code-based context or documentation, those cached inputs drop by 90% to 30 cents per million tokens, which makes running iterative agent loops significantly more affordable. For testing, you can access K3 today on Kimi.com. Developers can use the API immediately through the OpenAI compatible SDK, and it is already supported in major coding extensions like Kimmy Code, Claude Code, and Qwen. While the model supports a full 1 million token context window, there are some practical limitations to keep in mind regarding the open weight release on July 27th. This is a 2.8 trillion parameter model. You will not be running this locally on standard consumer hardware. Moonshot recommends a cluster of at least 64 enterprise GPUs just to serve the model. The weights are expected to ship under a modified MIT license, similar to the K2 family, though Moonshot hasn't formally confirmed the exact terms yet. Realistically, self-hosting will be restricted to enterprise infrastructure, research labs, and cloud providers like OpenRouter or Fireworks. Additionally, K3 currently only supports its max reasoning effort mode. It is configured to think at maximum depth for every prompt, which yields highly accurate reasoning but limits generation speed to about 60 to 80 tokens per second. Faster inference modes are expected in the future. Lastly, the built-in web search tool is currently undergoing updates, so developers building search-dependent agents will need to route queries through external search tools for now. Ultimately, Kimi K3 represents a significant closing of the gap between open weight and proprietary AI models. The weights drop on July 27th, and you can try the API today. Let me know your thoughts on this architecture in the comments. Thanks for watching, and I'll see you in the next video.